3 of topics 3 and 4, we will be talking about currents and circuits. There are two types of currents. The first is direct current, or DC. Current that flows in only one direction is referred to as direct current. Examples of this electrons move from the negative pole to the positive pole. Examples of these are batteries and solar cells. Alternating current, or AC, is a two-way current. Electrons move back and forth. An example is anything that plugs into a wall. So the chart here is an example of alternating current, where positive, negative, it flips back and forth. Circuits, charge, and fields. If you'll remember, a separation of charge creates an electric field. Within an electric field, electrons move, and the movement of electrons creates a magnetic field. So in the first picture, you have no circuit. So the circuit's broken, there's no current flowing, and there's no magnetic field besides the Earth. So the compass points to the Earth's magnetic pole. In the second picture, you have a completed circuit, so that completed circuit is creating a magnetic field, and the current flowing produces a magnetic field which reacts with the magnet in the compass and causes it to point towards the magnetic field produced by the wire and the battery. Electron flow produces a magnetic field. Notice that there's a similarity between the loop of wire, the magnetic field caused by the loop of wire, and the bar magnet. The electrons flowing through the magnet induces a magnetic field, very similar to the permanent magnet. The left-hand rule says that the left hand is the shape and direction of a magnetic field, so the thumb points in the direction of electron flow. The direction of the magnetic field is determined using the left-hand rule, so that the fingers sort of point towards where the electrons will flow. The right-hand rule shows you the direction of conventional current, so the direction that the positive charge will flow. Both rules work, but you have to remember that the left hand is for electrical flow and the right hand is for conventional current. Magnetic fields can be intensified by wrapping several loops of wire that carry a current around a piece of metal like iron, so a ferromagnetic core. You can create an electromagnet. The interaction between the electromagnet and the permanent magnet led to the development of the telephone. So you'll notice that as you either increase the amount of electricity or current going through, or increase the number of coil of wires, you can increase the magnetic field produced by an electromagnet. Bell's telephone. Alexander Graham Bell was the inventor of the telephone. This technology is still used today. It uses things like a diaphragm, a carbon block, carbon granules, an electromagnetic coil, a diaphragm, and a permanent magnet. How did it work? When you speak into a phone, a conventional phone, it vibrates a diaphragm. The carbon granules become compressed, and this compression changes the resistance. The current changes to mimic the voice changes. These current changes are then passed on to the electromagnet in the earpiece and the induced magnetic field produced by the electromagnet interacts with the permanent magnet. The force pulling on the diaphragm changes and produces a copy of the sound wave that was produced on one end of the phone.